we are going to solve this problem called the hurdle race. So it's actually a video game. It is a game that which character competes in a hurdle race. The hurdles are varying heights, and the character have a maximum height they can jump. So we have a character of game, and we originally have a maximum height that we can jump, and then there is a magic potion that they can take to increase their maximum jump. Okay, how many dose of potion must be the character take to be able to jump all of the hurdles? If the character can already clear all the hurdles, return 0. So let's say we have hurdles with different heights, is 1, 2, 3, 3, and 2, and the character can only jump with height 1. So the originally we can jump 1, right? But the harder height is 3. So we must take 2 more potions to be able to jump out of the hurdles. So yeah, so let's check the input before. The input is space pattern integer n and k, the number of hurdles, and maximum height of the character can jump naturally. Okay, second line contains n space characters, integers, and then here's the input. You have 1, 6, 3, 5, 2. 5 is the case, 4 is a natural number a character can jump. So if 4 we jump 1, of course we are able to pass it, but 6 we cannot pass it. Nah, what we do is we return the tallest hurdle minus the maximum jump, that is the number of potion the character should take, like that. So 6 minus 4 equals 2. So he need 2 more dose of potion to be able to pass the height of 6 hurdle. For another case, this character can jump 7, and the hurdles are 2, 5, 4, 5, 2, which is he is able to pass all of the hurdles, so we return 0. Okay, I think what we could do is first we have k, right? K is the natural jump, and height is the hurdles height. It is form of array of integer. So what we can do is first we loop all of the hurdles. What we do here, we check if our natural jump can actually pass the hurdles. We pass the hurdle then. So if the case that the hurdle is higher than our natural jump, we return the height of the hurdle minus the natural jump. So what we can do is we check if our natural jump is lower than the height, the hurdle. Then what we do is we return the hurdle minus k. If this is not returned during the loop, then the last thing we do is we return 0, because it means that this character can pass all of the hurdles. If this if is not returned, and then we return 0, which is he passed all of the hurdles. Okay, so let's do it. So first we loop all of the hurdles, so we can just use for each here, or maybe you wanna use the old way of for, like for e in 0 till the height, or you can use the array, but I think I will just use the value, so I will just use for each, which is for I in all of the height, and then I check if k is below the hurdle, which is the I, and then I return I minus k. If this if is not being called, or the if is never true, and then it will just return 0, because it means that this character have passed all of the hurdle, and there is no higher hurdle that this character cannot pass. Okay, maybe this is enough for the code. Maybe we just run one time to check if this is true. Yeah, we passed sample test case 1 and sample test case 2, and then yeah, maybe we just submit the code to check if we pass and we cover all of the sample, all of the test case. Yeah, what we do is we check on every hurdles. If we found a hurdle that is higher than the natural jump we can jump, and then we return the number of those of portion that we need to take, which is the I, the harder height, minus the natural jump. If we unable, if we actually can pass all of the case, and then we just return 0, which is this character can pass all of the hurdles. Alright, so yeah, we got our second star of problem solving here. You have on your second star, right? Very cool. Oops, I think we got 2 wrong answer. What is this? Okay, we have 2 wrong answer. Let's check it one more time. Let's back to the problem. What we do here is we loop all of the height, right? And then we check if there's higher. If we found this higher one, we just return the I minus k. Okay, the edge cases here. What if there is more than one higher hurdles? Let's say we found we can jump, or like this problem. Yeah, the sample input 1, we can actually jump 4, naturally jump 4, and in this we actually found 2 higher hurdles, right? That is 6 and 5. I think the test case 2, or test case 0, we found that the highest hurdle is in the front. So this code that we wrote is true, is gonna be right. But what if the highest hurdle is actually at the back? Let's say the 6 is actually at the position of hurdle 2, and 2 actually the position 6, which is we actually found 5. The moment we found 5, we just return 5 minus 4, right? 5 minus 4, which is 1. But what if uh, we want the next hurdle is 6? We actually need to add one more, right? Okay, so I think what we can do here is we can just loop to the end to check if there's a higher one, or actually we can just loop to get the max of the hardest and then just subtract the max. Okay, maybe you can do that. Okay, so we loop all of the hurdle, and then we maybe here we got our value. Let's say val equals hurdle minus k, and then at the end we just return val. Oops, val. Yeah. Okay, so we change this to val I minus k, and we return k. Yeah. But how do we know if we actually found this val is k lower than I? I think we can just make another approach of this is we get the max and then we just check if the max is actually higher than the k. Okay, this one is first approach. This we need to know is we maybe has flag true here, and then if we have flag true, and then we return the file. Let's say flag, if flag true, and then we return the val. If not, we return 0. We can do something like this, but I think I will go with another approach. Another approach is here. Let's say I have var max, it is equal head, the first head hardest, and then I loop inside the head just to get the max, and then here I will just max equal I, and then we got the max, right? We got the max value. The second thing we need to do is we check if is k lower than max. Yeah, we need to k max, and then we return the max minus k. Yeah, we could do something like this. So we got the max value, the max highest or the highest hurdles we found, and then we check if the k is actually lower than max, the highest hurdle. We just return the highest hurdle minus the natural jump, the k. That is what our portion. If this is not true, we just return 0. We just run one time to check if we did true. Okay, maybe just submit the code to check if we cover all of the test case. Alright, we passed all the test case. Yeah, that's maybe the problem. We need to put attention to the edge cases. It is when, for this problem is when we found more than one higher hurdles. Yeah. Okay, so that's it. We solve it. So the approach we did is we get the max for all of the hurdles, and then we got the highest hardest height, right? And then we check if our natural jump is actually lower than the highest hardest, then we return the highest hardest minus k, which is the natural jump. And then if it is not true, and we just return 0, which is we pass over the case. Yeah, that's it. We solve the hurdle race.